You think time is just time, a straight line, past behind you, future ahead, always moving forward. It feels like the most obvious thing in the world, right? But why? Why can't you remember tomorrow? Why does heat spread out and never gather itself back up? Why can't you unmix cream from coffee, even though nothing is physically blocking the atoms from doing it? Most people never really ask. They just repeat a word, entropy, as if naming the thing explains the thing. But that's not an answer. That's just a label pasted over the mystery. The real question is deeper. Why does entropy have a direction at all? Why does the universe behave like there's a built-in arrow? Because here's the strange part. Most of the laws of physics don't care which way time points. If you run the equations backward, they still work. And yet your entire existence doesn't. Your memories don't. Your body doesn't. Your history doesn't. Time feels one way. So what's going on? Let me show you. Start with something simple. A cup of hot coffee on a table. You pour the coffee, it's hot, steam rises, the mug burns your hand. Then you wait, the steam fades, the mug cools, the coffee drifts toward the temperature of the room. So normal you barely notice it. But notice the direction, hot to cold, not the other way. Now take a drop of perfume in one corner of a room. At first, only that corner smells. Then the smell spreads, it fills the air, soon it's everywhere. It never gathers itself back into one perfect corner, no reversal. And if you want the most dramatic version of this, drop a glass. It falls, it hits, it shatters. The world doesn't hand you the reverse movie. These are the kinds of changes you call time. Not because a clock told you, because your senses did. And you've seen them so many times that your brain starts believing something false, that time is a force, a current, a river pushing everything forward, like reality is being dragged from past to future, whether it wants to or not. But wait, nothing about the coffee contains a command that says cool down. Nothing about the perfume contains a command that says spread out. Nothing about the glass contains a command that says stay, broken. The atoms aren't obeying an arrow, they're obeying local rules. The atoms in hot coffee are just moving fast. The atoms in cold coffee are just moving slower. No atom is labeled past. No atom is labeled future. No molecule knows what a minute is. So why does everything you see behave like time has a preferred direction? Here's the key. You're not watching atoms, you're watching probability. And once you see that, intuition breaks. Imagine I show you a video, a close-up of tiny particles bouncing around. No labels, no sound, just motion. And I ask one question. Is the video playing forward or backward? Your instinct says yes. Of course you could tell. Forward feels normal. Backward feels wrong. But at the microscopic level, it's not so simple. Because the basic rules that govern motion forces, collisions, trajectories, they don't automatically pick a direction. If a particle can move from point A to point B in 1 second, it can move from point B to point A in 1 second. A collision that can happen forward can happen reversed. A molecule bouncing off another molecule doesn't come with a timestamp. From close enough, the universe is just motion. And motion doesn't announce which way time is supposed to go. Now push that one step further. Imagine you could freeze the universe for an instant, stop everything, then reverse every particle's velocity perfectly. Every atom that was moving right now moves the other way. Every molecule that was spinning now spins backward. If you could do that with perfect precision, the system would retrace its steps. The shattered glass would reassemble, the perfume would unspread, the coffee would warm itself back up. The catch is precision. To reverse a real system, You don't need almost perfect. You need perfect. Because a world with huge numbers amplifies tiny errors. Get one molecule slightly wrong, and the reversal collapses into a completely different future. This isn't philosophy. It's the brutal sensitivity of large systems. When there are countless particles interacting, the future depends on microscopic details you can't control. So reversibility is not absent because nature prohibits it. It's absent because you can't hold the system still enough to do it. Reversibility isn't absent in principle. It's absent in practice. But wait, if the laws don't prefer a direction, why does your world feel like forward is real and backward is a fantasy? Because you don't live in the world of one atom. You live in the world of huge numbers. And huge numbers don't just change how things look. They change what is possible. So what is entropy? Most people say disorder, but that's not an explanation. That's just a vibe that sounds correct. Entropy is counting. It's counting how many microscopic arrangements correspond to the same macroscopic state. In other words, how many different ways can the atoms be arranged while still looking the same to you? Because you don't see molecules, you see outcomes. You see hot or cold. You see mixed or separated. You see intact or shattered. And this difference matters. A macroscopic description is cheap. It takes a few words: hot coffee, cold coffee, perfume everywhere, glass on the floor. But a microscopic description is expensive. To specify the exact state of the system, you'd need the position and motion of every molecule, not a summary, not an average, everything. And here's the trick. One macroscopic state can hide an enormous number of microscopic states. That's entropy. Think about a deck of cards. There's one arrangement that looks perfectly ordered, but almost every other arrangement looks messy. So if you shuffle a deck, it drifts toward messy patterns. Because order is rare, low entropy means there aren't many ways to be in that state. High entropy means there are tons of ways to be there. And once you frame it like that, the arrow starts to look inevitable, because systems don't move through one possibility. They move through many. They jitter, they wander, they explore whatever states are accessible. And when a system explores, it spends almost all its time where almost all the options are. That's the entire idea. In one sentence, most of the universe's possibilities look high entropy. And this is why heat behaves the way it does. Hot coffee is just molecules with more energy on average. Put it in a cooler room, and collisions spread that energy outward. Energy spreads, and notice what's really happening. You're not watching temperature move. You're watching energy get redistributed among more and more particles. There are many more microscopic ways for energy to be shared out evenly than to be concentrated in one place. That's the counting again. A clump of energy in one region is a special arrangement. An even spread of energy across everything is a typical arrangement. So coffee cools for the same reason perfume spreads. Not because nature has a preference for cold or mixed, because there are more ways to be evenly distributed than concentrated. That's the arrow hiding in plain sight, not a force, a numbers problem. Here's where intuition completely fails. A cup of water contains on the order of 10 million trillion molecules. 10 million trillion. Pause. Your intuition cannot work at this scale. At this scale, probability becomes destiny. Meaning, once you let the system run, the outcome isn't chosen, it's selected by sheer weight of possibilities. The universe doesn't have to aim. It just falls into the region that dominates. And that dominance is so extreme that your brain interprets it as certainty. With numbers like that, the space of possible arrangements becomes absurd. There are unimaginably many ways for those molecules to be mixed and unimaginably few ways to be unmixed. So the system drifts from rare states to common states. It's not forbidden, it's overwhelmed. Here's the key: entropy isn't a force. It's what most likely looks like when you have huge numbers of moving parts, and most likely becomes so overwhelming that it looks like a law. So what does that imply? It implies the arrow of time isn't written into the microscopic equations. It emerges from counting. It emerges from statistics. Now the question everyone secretly asks: if the laws allow reversals, why can't coffee unmix? Why can't perfume unspread? Because the reverse states are not illegal. They're just astronomically unlikely. When cream mixes into coffee, it's not locking into place. It's just spreading out through random motion. Every molecule is bouncing, colliding, wandering. Over time, those random steps smear the cream everywhere. And once it's smeared everywhere, there are practically endless mixed arrangements. Could the molecules wander back into a perfect unmixed state? In principle, yes. But yes stops meaning anything when the probability is this extreme. It's like one chance in a one followed by more zeros than you could write in your lifetime. That number isn't there to impress you, it's there to show you something uncomfortable. Once the numbers get that large, allowed, and practical stop being the same word. The reverse movie requires a conspiracy of motion. It requires countless molecules to coordinate their random wandering into one specific arrangement, all at once. Not because a law says no, because the universe has too many ways to say anything else. That's not unlikely, that's never. This is what irreversibility looks like at scale, because irreversibility is the cost of not knowing. To run the movie backward, you'd need the exact microscopic state, not the temperature, not the smell, the exact positions and velocities of every molecule. When the perfume spreads, that information gets shredded into the details of countless collisions. When the coffee cools, the extra energy gets shared out into microscopic motion everywhere. When the glass breaks, the exact impact throws information into 1,000 tiny vibrations and deformations you will never track again. And once that information is scattered, the reversal isn't just hard, it's inaccessible. Not because the universe locks the door, because the key is a description of more moving parts than your mind can hold at once. So the arrow of time is also an arrow of lost control, lost detail, lost precision. Forward is what happens when you only know the large-scale story. Backward would require knowing everything. And now you can see why your everyday examples feel absolute. Hot coffee cooling is the system sliding into a typical state. Perfume spreading is the system sliding into a typical state. Glass shattering is the system sliding into a typical state. In each case, the reverse isn't banned. It's drowned. Drowned in the ocean of all the other ways the particles can be arranged. Here's the next step, and it's the one most people miss. The arrow of time isn't only about coffee and perfume. It's also about memory. Why do you remember the past, but not the future? It's tempting to say, because the past already happened. But that's not an explanation. That's just repeating words again. So let's make it concrete. A memory is not a ghost. It's not a magical imprint. A memory is a physical arrangement of matter. Something in your brain changes. Connections strengthen. Molecules shift. Energy is spent. A stable pattern is created. That stability matters. Because stability is what makes a record. A fossil is a record. A photograph is a record. A footprint in sand is a record. A scratch on a surface is a record. The past leaves traces. That's why you can know it, because it has been stamped onto the world. The future hasn't left traces yet. So you can't remember it. But wait, why does the past leave traces at all? Because making a stable record requires an irreversible process. You have to push matter into a configuration that will hold. And that pushing always creates waste, it always creates heat somewhere, it always increases entropy in the surroundings. Even machines do this. Every time a computer saves information, it rearranges charges into stable differences. And when you erase information, when you force many possible states back into one, you pay a minimum cost in heat. Information has a thermodynamic price. So the arrow of time isn't just about coffee cooling, it's about what the universe allows you to preserve. You can't know the future the way you know the past, because the past leaves trails, and trails spread outward. One event doesn't stay one event. It becomes many copies of itself. Light bouncing off it, sound carrying it, heat leaking its details into the air around it. The past is easy to find because it has multiplied itself into the environment. The future can't do that because it hasn't happened yet. So time's direction isn't just in clocks, it's in evidence. Time isn't a force pushing events forward, it's what probability looks like when a universe starts ordered. So let's bring this together. If the arrow of time comes from probability, and probability comes from entropy, the next question is unavoidable. Why was the past low entropy in the first place? Why did the universe begin in a rare, ordered state? That's where the question stops being comfortable. Think about the direction we've been moving. Hot coffee cools because heat spreads out. Perfume spreads because mixing increases. Glass shatters because there are more broken configurations than unbroken ones. Memories work because the past leaves traces. All of these arrows point the same way, toward higher entropy, toward more probable states. But none of this works unless the universe began with somewhere to go. Here's the key. Entropy increasing needs a low entropy beginning. If the universe started already at maximum entropy, there would be no arrow. Everything would already be as mixed and as spread and as even as it could be. No gradients, no differences, no heat flow, no engines, no chemistry doing anything interesting, no life, no memory, no history. So the arrow of time isn't just the way things go. It depends on a special beginning, a starting condition. Our universe had to start unusually ordered in a specific sense, not typical, not the most likely state. A state full of usable differences, differences in temperature, differences in density, differences that could relax. And once that condition exists, everything else follows. And you can feel this hill idea everywhere. Anytime there's a gradient, there's a direction built in, a hot thing next to a cold thing, a concentrated smell next to clean air, a pile of broken fragments next to the one arrangement you actually wanted. The gradient is the stored potential, not in the poetic sense, in the statistical sense. It's a state with fewer ways to be, a state that stands out from the crowd. And once the system is allowed to wander, it falls into the crowd. That falling is what you call time passing. That's why clocks work, too. A clock is just a system designed to change reliably, a repeating process that produces marks you can count. But the clock isn't creating time. It's riding the same one-way drift, stable records accumulating in one direction. The only reason you can measure time is because the world keeps moving into new states and leaving old ones behind. Because entropy isn't what time does. Entropy is what probability does when you give it structure to erase. Here's the structural reframe. Time is not a thing pushing the universe forward. Time is what you get when the universe moves from unlikely order into likely disorder. Past feels fixed. Future feels open, because the universe carries evidence forward and leaves it behind. Pause. Think about what that means. The flow of time is not some fundamental river. It's the statistical avalanche of the universe relaxing. And you are inside that avalanche. You are made of it. Your body is a chemical machine that runs because gradients exist. Your thoughts happen because energy differences exist. Your memories exist because traces can be written. Every breath you take is a flow from one state to another. Every step is energy turning into heat. Every thought is order built locally while disorder is dumped elsewhere. That isn't a metaphor. It's the bookkeeping of physics. So what does that imply? It implies something shocking. The forwardness of time is not locked into the microscopic laws. It's locked into the starting condition of the cosmos, which means when you ask, why does time only move forward? You're really asking, why was the beginning so special? And that is not a small question. That's a question about why there is history at all. Now let's make this real. Look at a machine. Any machine that takes energy and does work. An engine, a refrigerator, an air conditioner. It always has a side effect. It produces waste heat. Always. A refrigerator does not create cold. It moves heat from inside the fridge to the outside. And in the process, it dumps even more heat into your kitchen. That's why the back of a fridge feels warm. It's not bad design. It's not because we haven't engineered it well enough yet. It's because moving heat against the natural direction costs energy. The arrow fights you. And the payment is entropy. Engines are the same. You can take heat and turn some of it into useful work, but never all of it. Some always leaks away into unusable heat. That's not a limitation of technology. It's a property of time's arrow. Because turning heat into work is like trying to unmix the universe. It's trying to reverse the drift. And the universe charges a tax for that, a minimum cost, a one-way leak into heat. So the arrow of time is not just philosophical. It shows up as a hard boundary in the world, a constraint, a limit, a law written into engineering. And this is why perfect efficiency is a fantasy. Every useful action has a footprint. Friction, resistance, tiny vibrations, heat. You can hide the waste. You can move it somewhere else. You can make it smaller. But you can't make it vanish. Because a machine is made of atoms. And atoms obey statistics. The moment you have moving parts, you have countless microscopic degrees of freedom. And energy leaks into them because there are so many places it can go. That's what waste heat really is. Energy falling into the space of possibilities you don't care about. And notice how close this is to the coffee example. The coffee doesn't decide to cool. It has 1,000 pathways for energy to spread out, and almost no pathways for energy to concentrate back into one place. Machines are trapped by the same landscape. Work is the rare, directed outcome. Waste is the typical outcome. So engineering doesn't just reveal the arrow of time, it proves the arrow is structural. It's baked into what large collections of particles do when you try to push them around. Now, here's another way to think about it. The past feels real because it left records. The future feels unreal because it hasn't. And those records aren't floating in some abstract realm. They're physical. They're scratches, signals, photons flying through space, ripples spreading outward. Once an event happens, it sends out consequences. It leaves traces that can be copied and copied again. The now of an event expands outward as information, and the universe fills with evidence. That evidence never gathers itself back up into silence. It spreads. And once you notice this, you start seeing it everywhere. An event happens, and the universe broadcasts it. Not intentionally, automatically. Light reflects off surfaces and flies outward. Sound compresses air and ripples across rooms. Heat flows into nearby matter and changes microscopic motion. Even the simple act of touching something leaves a trail of tiny rearrangements. The world becomes a library of the past, And the library grows in one direction, because copying information into the environment is itself an entropic process. Each copy is a new arrangement, a new pattern held in matter, a new stable difference that didn't exist before. That's why the past feels fixed, not because it's locked in a vault, because it's been duplicated into reality so many times that you can't erase it without erasing the world itself. To undo the past, you would have to gather every scattered trace, every photon that escaped, every vibration that spread, every extra bit of heat that diffused outward. You'd have to unwrite history from the universe. And that is the true meaning of irreversible. Not impossible by law, impossible by scale. Impossible because the evidence is already multiplied. So time's arrow is tied to causality. Cause produces effects. Effects spread. Records accumulate. And the direction of time is the direction in which information becomes easier to find. The past is the direction of increasing evidence. The future is the direction where the evidence doesn't exist yet. So when you ask, why can't you remember tomorrow? The answer isn't mystical. Tomorrow hasn't left fingerprints on the universe. Today has. So by the time you reach this point, the question has changed shape. It started as, why does time move forward? But what you've really uncovered is, why does the universe keep producing differences and then erasing them? Why does it keep turning sharp patterns into smooth ones? Why does it keep taking concentrated energy and spreading it out? Why does it keep taking clean information and smearing it into heat? Because that smearing is what probability does. And you are living inside the smear. Your present is not a moving spotlight sweeping across reality. It's the thin edge of the avalanche, the boundary where new records are being written. The past is the region where records have already multiplied. The future is the region where they haven't. That's why time feels like a direction you can't escape, because the universe keeps moving from special states to typical ones, and it keeps leaving evidence behind as it goes. And once you see that, the arrow stops being mysterious. It becomes unavoidable. So why does time only move forward? Not because time is a magic conveyor belt, not because the universe has a preference for forward, but because probability does. Because when you take a universe of huge numbers and you start it in a rare, structured state, it almost certainly slides toward more probable states. Heat spreads, mixing increases, records multiply. And that one-way slide is what you experience as time. You feel it as aging, you see it as history, you carry it as memory. You are not watching a clock tick, you are watching the universe relax. You are watching improbability dissolve. And somewhere inside that process, a thinking organism looks up and asks the strangest question of all. Why is it like this? Why does the universe have a past that's different from its future? And the honest answer is not a final answer. The honest answer is because the beginning was special. Because the universe started in a state that made an arrow possible. And that raises the next question. Why was the beginning so low entropy? Why did the universe have that structure at all? That's where the mystery moves next. Not because science has failed, but because this is exactly what understanding does. It pushes you to the edge of what you can explain and forces you to look over. The universe is stranger than intuition. And the fact we can even see the outline of the truth, that we can understand why time is hard, that might be the most extraordinary thing of all.